there, and we're going to discuss about access control list, ACL. Now ACL is a set of rules we create to block a network. For example, we have this network, and this network wants to block this network. For example, this is sales network. This is accounts network. This is marketing network, and we want this sales network not able to communicate with accounts network, but sales network can communicate with marketing network. So how it's possible? How can we do that? Is it possible really to block a network with ACL? So we will learn about that. So we're going to permit this network. We're going to deny this network. Okay, so now if we want this network not to communicate with accounts network, then we have to enable ACL to near the destination. Means this router is near to the desired network. Means we don't want this network to communicate with accounts network. That's the reason we have to enable this ACL in this router near to destination. Means if we want to disable this network not to communicate with sales, then we will enable ACL in this router. Same with the case with this. Means whatever a router is near to the home network will be allowed to communicate, or will be allowed to make a connection. So that to restrict that, we have to block ACL, block the network via ACL from the network. So this router is near to the destination, hence we are going to configure it. So enable configuration mode. Now here we have to give a first command, which is called access list. And you can see access lists are of two types: standard access list and extended access list. Means 1 to 99. We actually create, as I said, a set of rules. Means we create a set of rules via access list. We just give a number, give a sequence number, serial number. According to the serial number, we enable ACL. So 1 to 99, we are going to configure ACL via standard access list. Since we are using access list for the first time, that's the reason we're going to give a valuation of 1. Now simple source, we have to deny the network, deny the entire network, and the range we're going to deny is 192.168.2.0. This is the range, and here we have to give a wildcard mask. Now wildcard mask is broadcast mask minus subnet mask equals to broadcast mask. For example, the broadcast mask is 255.255.255.255 minus, for example, this is class C's network, so the subnet mask will be 255.255.255.0. so the equal value, the final value will come 0.0.0.255. so the class C's subnet mask will be 255.255.255.0. Here we give the value 0.0.0.255. so almost opposite. Now since we deny the network which is 192.168.2.0, but we have to permit the access list also. Permit for this network, which is 192.168.1.1. Also in near future, if this router start affording another home group, which is 192.168.4.0, 192.168.5.0, 6.0, 7.0, up to 21 network can be added to this router. So if we don't allow a permit masses, then it may restrict the entire network, may restrict the entire router group. So to sideline those, we don't want to block those network. That's the reason we have to give a command access list, which is the values 1, and then we have to permit, and then we have to permit any network. It could be 192.168.1 at current scenario, means 192.168.1.0, 0.0.0.255, but we want to permit any network. Now we just configure access list. So just wants to show goes to privilege mode. So show access list. You can see standard IP access list 1, deny. This is the deny network, and the bycom mask and permit. But we just configure access list. We not yet enable it. We not yet implemented it. One last command is needed, and it's needed in this network, since we want this network not to allow access. We don't want this network to access this accounts network, and only want this marketing network to enable. So that what we need to do, we have to create and we have to implement access list. We can implement access list via two types. One is inbound rule and one is outbound. Inbound means, for example, this is the inside network, means we send a packet and we are accepting the packet. If we implement access list via outbound rule, then the entire router network will be blocked. Entire router will be blocked. For example, in near future, if we want to extend the network from here, we want to extend a router here, we will not able to, because we restrict and we block the network from outside. But we should block the network via inside, because in near future, not only we can add a router here, we can even add a serial we can add even switch here, more and more end devices here to expand our internal network. So for that, we have to configure inbound rules. So this access list will be configured in the fast Ethernet port. This fast Ethernet port 0/0. Okay, done. Now IP access group is 1, and we have to implement a outbound rule, so that our traffic get filtered. So means this is how outbound means our packet is moving to outside and packets is entering from inside. So this is inbound and this is outbound. Our packet is moving to the router, means exiting to the router, so out, and entering to the router means in. So we want to filtering our packets from inside only. We want to block the packets from inside only. So that's the reason out means we don't want our packet to exit and not wants to exit from entry also. So now what we're going to do is go to PC. Now since routing is enabled, we will able to get a ping command. Let's try to access 2.2. Request timeout. Request timeout. Request timeout. Request timeout, but we will able to ping with 192.168.1.2 because we enable routing, so no doubt it will be start pinging. Yes. So this is how we configure ACL, the standard ACL for the entire network. We are blocking the entire network via standard ACL. Lots of tricks are there to use ACL. But currently we just getting timeout RTO message at 192.168.20 network. It would be with 2.3 also. So I hope you learned something about the standard ACL. Here we go. And we blocked the entire network of standard ACL. So I hope you learned something from it. Thanks for watching.